Salutations, mini mathematicians. I hope you're having a fabulous day. We're going to be going over 7.2a lesson today. 7.2a lesson is about absolute value functions. Before we get started, Pi, hanging out, coworker. Pi. There she is, just hanging out in the background. Anyways, hope you're having a great day. Like I said, 7.2a, absolute value functions. Our purpose today is to be able to describe in words, create a sketch of a graph, and or write an equation, a rule, function rule, of the transformation of an absolute value function from the parent function. So every absolute value function is going to kind of follow this format. And depending on what we change for A, H, and K, our graph is going to have a certain type of transformation based on how it's affecting our output. So X is still our input and F of X is our output. So let's get started. 7.2a lesson, absolute value functions. So we're going to be using the equation y equals the absolute value of x to complete the following. And we're going to call this our parent function right now. It's kind of like our base where we're going to grow. We're either going to grow bigger or narrower or shift up and down. Ooh, better word than shift for graphs. Translate. Translate vertically up, down, or horizontally left and right. Okay, so like I said, absolute value is the distance from zero. It's always a positive amount. So here the absolute value of -4 is 4. So the absolute value of what number is 1? And notice we already have 1 here. So this is going to be -1. Ooh, does that make it seem like there's going to possibly be some symmetry going on? I think so. So taking a look here, what number is 0 away from 0? 0. 1 is 1 away from 0, and 4 is 4 away from 0. So notice we do have kind of this symmetry happening in our table. So from here, we know that we're not going to have a linear function. And we've looked at this in our last lesson, and it makes kind of a V shape. So we're going to look at a mapping. And remember, a mapping we're going to list from least to greatest without repeating any values. -4, -1, 0, 1, and 4. And the same thing over here for our, remember we can call this our domain and this our range. This is our input, then that is our output, exactly. So here, from least to greatest, it goes 0, 1, and 4. And then I'm going to draw directional arrows. -4 is mapped to 4. -1 is mapped to 1. 0 is mapped to 0. 1's mapped to 1. And 4 is mapped to 4. So just looking at our table, we know that this is a function because every input has its own unique output. And here in our mapping, every x value only has one line coming from it, which means every x value corresponds with just one y value. Given my x, I can determine the unique y value. Okay, so from here, what we're going to be looking at is we're going to graph this equation now. So we have our vertex at 0, 0. And then 1 goes to 1, -1 also goes to 1. And then we went all the way to 4, 4, and -4, +4. So if we take a look at this, let me use my straight edge here. We notice we have this symmetrical shape that looks like a V. Where every input and its opposite have an equal output. So why is this graph of a V? Well, that's because any number and its opposite have equal absolute value. We can also say something like the absolute value of any positive number or negative number will always equal a positive number. Therefore, every y value except for 0 is going to relate to two x values. Every input except 0, because 0 doesn't have an opposite, has two outputs. Cool. So taking a look here, is this equation a function? So there's a couple ways we can look at this equation as a function. One way we can look at is the table. We can look at the mapping and we can look at the graph. Remember, we have such a thing called a vertical line test. So I might say, have your function detectors out. I have my function detector right here. I'm going to sweep it through my graph. And as long as my vertical line only intersects my graph at one point at any time, not more than 1 point, I know I have a function. If I did intersect the graph at more than 1 point, that means there's a vertical segment or vertical 2 points, two inputs that have the same outputs. One input that has the same output, and that would create a vertical line, or my vertical line would intersect the graph at more than 1 point. So here, is this equation a function? Since it did ask for equation, we can talk about the actual equation. Yes. Y equals the absolute value of x. Each input results in only one output. Given an x value, there's only one y value. Perfect. So that's a little bit of introduction to absolute value, and now we're going to do some stuff to it. I'm going to manipulate it. So let's take a look. We have y equals the absolute value of x. I'm going to keep that as my parent function. I'm going to highlight it in a same color as above, just to keep my mind organized. And now we're going to look at this other function. And notice, just looking at the graphs, there's a lot of things that are different and similar here. So how are these graphs the same? How are they the same? Well, they both have a V shape. They both open upwards. Sometimes I call them happy absolute values because they kind of look like a big smile. So they're happy, we can put there. And I guess both graphs have symmetry. So that kind of connects to the V shape. Both have symmetry. Meaning I could fold them. Okay. Explain how they're different. Well, y equals 1/2 x minus 2 is, would you say, like, it's wider? It's wider. Which graphically and mathematically we can call that, does it make it steeper or less steep? Less steep. And it's translated or shifted which direction? To the right. Translated or shifted right. You could also say horizontally, or you could say along the x-axis. Notice it's moving along the x-axis. So how is our image shifted from our pre-image? Remember, our pre-image is where we start, and name the transformation being shown. Well, we kind of talked about that above. We said translated right. I'm going to tell you a secret here. I'm going to tell you how many units it's translated. is translated right 2 units. Mrs. Barr, how did you know it was 2 units? Well, let's look at that equation a little bit closer and think about how I knew it was 2. Think about how x, if I do something on the inside of this absolute value, I'm affecting x, my input. If I'm doing something on the outside of the absolute value, I'm affecting y, my output. Y controls vertically, x controls horizontally. Okay, let's keep going. Without graphing, we're going to make a prediction about how the graph of y equals the negative absolute value of x is going to be different from our parent function y equals the absolute value of x. Well, one way we can do this is kind of making a table down here. So let's thinking about this. Whatever my input is, it's going to become positive because of the absolute value. But then, no matter what, it's always going to be negative. So my output is always going to be negative. Always negative output. So if I make a quick sketch, before we had always a positive output from my origin 0, 0. Well, now we're always going to have a negative output. So maybe it's going to look something like my green function. So let's take a look. So we're going to compare y equals the negative absolute value of x and complete the following. So A, complete the table of values. Well, we already know this table is our parent function or our pre-image. So that's 4, 1, 0, 1, and 4. And now with our image, we're always taking the absolute value and then taking the negative of it. So this is going to be negative 4, negative 2, 0, negative 2, and negative 4. So notice we still have this really pretty symmetry going on. So complete table of values, check. Graph each equation in the same coordinate plane and label your graphs. Okay, so we're going to have our parent function, 0, 0, 1, 1, negative 1, 1, 4, 4, negative 4, 4. It is helpful to use 2 colors here, but not necessary. So that's our parent function. I'm going to label it y equals the absolute value of x. And then I'm going to graph my image, 0, 0, negative 2, negative 2, 2, negative 2, 4, negative 4, 4, negative 4. Very nice. And this is y equals the negative and then absolute value of x, making all our outputs negative. So taking a look here, was our prediction correct? Why, yes, it was. How is the graph of y equals negative absolute value of x being transformed to make our new graph? Well, what is this called? We go from here to here. We're kind of flipping it over, right? So we can call it a reflection. Y equals negative absolute value of x is a reflection of y equals the absolute value of x across the, which axis is this? X-axis. X-axis. So we sometimes call this a flip or a reflection. And we can also kind of call it a 180-degree rotation, but the reflection is the most appropriate and most efficient way to explain this transformation. Without graphing, so now we're going to have a third transformation here. We're going to make a prediction about y equals absolute value of x plus 2, and it's going to differ from y equals, and sorry, that got cut off, the absolute value of x. So remember, that's our parent function. Okay, well, thinking about this, x plus 2, we're always going to add 2 to the number on the inside and then take the absolute value. So since we're always adding 2 and then taking the absolute value, do you think this is going to translate up, down, left, or right? We are affecting the x value. Remember, x controls the horizontal distance. So what do you think your prediction is going to be? We're going to translate along the x-axis or horizontally. But how many units do you think? And which direction? So that's the big question. And if we go back to our other transformation we looked at, I told you x minus 2 is going to translate right to. So maybe that gives you a big hint. Well, let's take a look and complete our table of values and take a look at it on the actual graph. So we're going to complete our table of values. So here, negative 4 plus 2 is negative 2, and the absolute value of that is 2. I guess I should use a different color. Purple, 2. Negative 2 plus 2 is 0, and the absolute value of 0 is 0. 0 plus 2 is 2, and the absolute value of that is 2. 2 plus 2 is 4, the absolute value of that is 4. And 4 plus 2 is 6, and the absolute value of that is 6. So taking a look up here, we're going to have negative 4, 2. Negative 2, 0. 0, 2. 2, 4. And then 4 would be 6, which would be somewhere about there. Ski. Okay, I'm going to use my straight edge and notice what is happening from my parent function, which was my pink one, to this image. Remember, this is y equals absolute value, and on the inside, it's x plus 2. On the inside, it's x plus 2. So taking a look here, we are going to have a translation horizontally, which we agreed on. But what direction were we translating? We translated to the left. Interesting that we are adding 2, but we translated to the left. Okay, so translate left 2 units. And one of the reasons that is thinking about your vertex, where we're changing from that negative slope to that positive slope. Here, that's going to be what makes your output 0. So when you're thinking about that, what value here for x is going to make that 0? It's negative 2. So because we're adding 2 to each value, that's actually going to shift our vertex to the left, because negative 2 plus 2 is going to be 0, and the absolute value of 0 is 0. So we want to always be thinking about, because 0, the only absolute value of 0 is 0. 0 doesn't have a negative. That is why 0 is the only input that has one output. So we want to find that absolute value of 0. So whatever x value that makes that 0, that's going to be where our vertex is, and that's going to help tell us how far we're translating and in which direction. Cool. So let's continue. Let's look at some more of these graph transformations. So the only value we haven't looked at yet is when we are adding or subtracting on the outside. So remember, thinking about adding or subtracting on the outside of the absolute value, that's not affecting x at all. It's only going to affect y, our output. So thinking about that, how is this going to translate our graph? Do you think it's going to change up and down, the y direction, or left and right, our x direction? And I'm sorry that that keeps getting cut off. So now what we're going to be looking at is we're going to be looking at y equals absolute value of x all plus 3. So all outputs, y values, plus 3 means translate vertically up 3. And let's see what that looks like in our table and on our graph. So here, taking a look at our table, we're going to take the absolute value of -2 and then add 3 to it. Absolute value of -2 is 2, and then add 3, we get 5. Continuing on, absolute value -1 is 1, plus 3, we get 4. Absolute value of 0 is 0, plus 3, we get 3. Absolute value of 1 is 1, plus 3, we get 4. Oh, and we start to see that symmetry again. So I'm thinking this is going to be 5, and I'm right. Absolute value 2 is 2, plus 3 is 5. Cool, so we're going to graph and label this one. So here, we're going to see 0, 3. Sometimes I like going for my vertex because from there, I can really see that symmetry and make sure that I'm graphing correctly. So sometimes I really like to find like where is that vertex in my table to feel more confident when I'm graphing. 1, 4, -1, 4, -2, 5, -2, 5. Okay, so taking a look here, dun, 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 dun. This is y equals the absolute value of x all plus 3. So we labeled and we graphed it and we noticed, yes, we are just translating vertically up 3. Yes. You can also say translate along the y-axis if you wanted to. Okay, well now we're going to combine some of these transformations and see if we can put them together to make our new graph. So we're going to use the equation 4 times the absolute value of x and then -3. So notice this -3 and that 4 are both going to be affecting our output, which is our y amount. So this -3 is going to do what to our graph? It's going to translate down 3 units. And this multiplying by 4, is this going to make our graph grow faster or slower? So thinking about, is this graph going to grow faster or slower? If all my inputs I multiply by 4, is multiplying by the number 4 getting you bigger numbers or smaller numbers? Way bigger numbers. 4 times bigger numbers. That means that this is going to grow faster. Then y equals the absolute value of x, which translates to the graph being steeper. So let's see what that's going to look like. Compare the table of values for our new graph. So now -2, absolute value of -2 is 2, times 4 is 8, and then subtract 3 is 5. And if you wanted to show a little bit of work to the side, feel free to do so. We can always show our work over here. So if I wanted to do -1, 4 times the absolute value of -1, all minus 3. Order of operations, we have to do the grouping, which is the absolute value function first. Absolute value -1 is 1. Then you have to multiply before you subtract 4. And 4 minus 3 is 1. Don't always just see 0 and think it's 0, 0, because remember, we could be translating left, right, up, or down. But in this case, we are correct here. Absolute value is 0 is 0. And then 4 times 0 is 0, but then you're subtracting 3. Because remember, we are translating down 3 units. So from our original vertex, we're going to be going down 3 from our parent function. Absolute value of 1 is 1. 1 times 4 is 4. 4 minus 3 is 1. Absolute value 2 is 2. 2 times 4 is 8. 8 minus 3 is 5. So notice we do have this symmetry again from our vertex, and I always like noticing what my vertex is. Next year in Math 1 Honors, Math 1, you'll be learning about an equation just to find the vertex of some of these functions, which is really cool. And you can do a lot of really interesting math by finding the vertex. So from here, we're going to graph on the same coordinate plane up here. So let's see. I always like graphing my vertex first. So 0, -3, 1, 2, 3. The power of the vertex. -1, 1. Wow. Really? -1, 1? Oh my goodness. Look how fast that is growing. 5. Oh my gosh, I have to go all the way out to... Okay, no. 2, -2, 5. Wow. It's growing just so incredibly fast. What a zoom! Like that graph sound? So then this one is y equals 4, growing so fast, multiplying by 4, times that's the value of x minus 3. Pi even got excited. I don't know if you can see her. Let's see. Check on Pi. Pi, are you excited about how fast that graph's growing? Yeah, so exciting. Okay. So we graphed it and explain in words how it differs from our parent function. So remember, our parent function is y equals absolute value of x. I like to make it pink just so we're consistent with my notes. Taking a look here, explain in words. Well, we translated our vertex down, so y equals 4 times the absolute value of x, all minus 3, is translated down 3 units, down 3 units from y equals absolute value of x, and is steeper, grows faster, narrower. Cool. So now we have another situation to look at, and we're going to be using this equation. So notice now the number in front on the outside is 1/4. So whatever happens on the inside, it's going to be 1/4 less. So is that going to make our function grow faster or slower? Think about that. So here, I've missed you too. Here, use the equation y equals 1/4 times the absolute value of x minus 1 to complete the following. Complete our table of values. So -3, and what's nice about these numbers we're going to use is they're going to be divisible by 4, which is pretty cool, pretty much. So that's why I'm picking these input values. So if I give you a table that's blank with input and output, think about numbers you can put for your input that are going to make your output more efficient, easier to graph. -3. -3 minus 1 gets you -4. Absolute value -4 is 4. 1/4 of -4 is 1. -1. -1 minus 1 is -2. Absolute value of -2 is 2. 1/4 of 2 is 1/2. Not too bad to graph. 1. 1 minus 1, 0. Absolute value 0, 0. 0 times anything is 0. 3. 3 minus 1, 2. Absolute value of 2, 2. 2 times a fourth, a half. Oh my gosh, you guys, take a look. I think we have some symmetry. Let's check this one, and hopefully we get 1. Fingers crossed. Let's see. 5 minus 1, 4. Absolute value of 4, 4. A quarter of 4, 1. Yay! Beautiful symmetry, which is telling me that this is going to be my vertex. Okay, complete the table. Check. 1 second while I plug in my computer. Okay. Take a moment to breathe. Why not? Okay. So, where were we? Oh yeah, we were going to graph this. I'm going to use orange just so it stands out a little bit. Okay. Taking a look, we have 1, 0 as our vertex, and that's because, remember, if we look at our equation, on the inside, we're subtracting 1, which means we're going to translate right 1. So that's what this is telling me. So 1, 0. And then if we go -1, a half, 3, so 1, 2, 3, a half. And then if we go to 1, if we go over the way to -3, 1, 2, 3, -3, we're going to go up to 1. Here, we're going to go over to 5 and up 1. It's going to grow so slow. Go. Here we go. And this is y equals 1/4. It's growing a fourth as fast, so it's going to be super wide. Absolute value of x minus 1. Excellent job. So part C on 10 says, explain in words how the graph of y equals 1/4 times the quantity of x minus 1 differs from the graph of y equals absolute value of x. So if we want to explain in words, we're going to talk about how we translated to the right 1 unit, and we're growing at a slower rate, a less fast rate, making this graph wider. So using our words here, the graph of y equals 1/4 x minus absolute value of x minus 1 is translated right 1 unit from y equals absolute value of x, our parent function, and grows at a slower rate, which we can call less steep, wider. When I've been thinking about wider graphs versus narrower graphs, I sometimes think about metabolism. So if you have a super fast acting metabolism, like our green graph here, remember at 4, like your metabolism's at a 4, usually those people are a little more skinnier, right? Less wide. My metabolism's super fast, less wide. Then if your metabolism works a little slower and you eat the same stuff, You work out the same amount, you're going to be a little bit wider. So this is your metabolism working slower. This is your metabolism working faster. So you can kind of think about it that way. You can also just think about how your output is changing from your input. Cool. So we're going to organize all that cool information into a fun table and connect it to an equation. So the general form for any absolute value function is y equals a times the absolute value of x minus h, all plus k. And how do these values of a, h, and k affect the graph of an absolute value function when it's compared to the graph of y equals absolute value of x? So if the value of k is positive, so remember that's kind of like if we had something like y equals the absolute value of x plus 5. Thinking about that. So when the value of k is positive, like this, we are going to translate up k units. Well, what if that value of k is negative? If we have a negative value of k, y equals absolute value of x plus negative 5, that's going to look like y equals absolute value of x minus 5 when it's completely simplified. So thinking about that, the graph is going to translate down k units. Guess I should put little quotes around the k. Cool. Well, let's take a look at some of the other ones. So when the value of a is negative. So when the value of a is negative, that's like having y equals the negative absolute value of x. So if we have a negative in front of there, remember all our outputs were negative. It made that sad absolute value right here. Remember this one? This made it sad. It was a sad absolute value. Clinical frown. So it's going to, the graph opens down. You can say flips or reflects across x-axis. Cool. When the value of a is positive, so if we have just y equals absolute value of a, that means we are open up, or just a happy absolute value. Here, remember, we're opening down. We're a sad one. Okay, when the value of a increases, so if the value of a is increasing from our parent function, thinking about that, we could have something like y equals 8 times the absolute value of x. Oops, this should have been an x here. Sorry, my bad. Y equals 8 times the absolute value of x. That's going to make it grow super fast. When it grows super fast, the graph's going to get really narrow. It's a super fast metabolism. So it's going to be steeper. Graph's going to be steeper and narrower. When the value of a decreases, what do we know about when the value of a decreases? So let's say from y equals the absolute value of x, we get y equals a third the absolute value of x. Then we're going to get less steep and wider. Okay, so what does the a control in the graph of y equals a times absolute value of x minus h all plus k? Remember that a gets multiplied after you take the absolute value, so it's affecting your output. It's making it grow faster or slower, or it's flipping it upside down. So the value of a affects the slope of your line, the slope of the graph, which includes direction. So we can say steepness and direction. Steepness and direction, really important that it affects both of those. What does the value of K control? K, remember up here, K is the value on the outside. So we already took the absolute value and we're only affecting the output Y. And Y controls that vertical up and down distance. So it's going to affect the vertical shift or translation up and down. Okay. H. What does H control in the graph? Well, remember, H was that number on the inside, and we looked at it a couple times, and H, kind of funny, it's also another word for eight that starts with an H, controls the horizontal direction. Okay. Affects horizontal translation. So if you have, remember, y equals x plus 2, that means left 2. Units, I think I can fit it in there, units. And y equals absolute value of x minus 2 means right 2 units. Cool. Let's take a look at the next directions. Describe in words how the given absolute value graph differs from the graph of y equals the absolute value of x. So this is always going to be our parent function we're going back to. Explain any transformations that might take place. So I'm going to do 12 with you, and then you're going to do 13, 14, 15, and pause me while you do, and then we'll check in. So number 12, y equals the absolute value of x minus 6. Well, that minus 6, sometimes I like to rewrite again this form of the equation, y equals ax minus h all plus k. Minus 6, that's an h value. Remember, that's on the inside, so it's affecting x. H, horizontal, it's affecting x direction. So we are going to translate 6 units right. Cool. So go ahead and pause the video and go ahead and do 13, 14, 15, and then we'll check back in. Make sure you utilize your little notes cheat sheet up here if need be. Okay, let's see how we did. 13, this is a negative 8. It's an a value, which is going to affect the steepness, the slope of our graph. So how is it different? Opens downwards. Opens down, or a flip or a reflection. Since it talked about transformations, we should say reflected. Oops. Y equals absolute value of x reflected across x-axis. And is it going to be steeper, grows faster? I guess it grows faster downward, grows slower downwards. It's going to go faster. Steeper, narrower. Cool. Next one, number 14. This is a fifth. It's going to make the graph be wider. It's growing slower at a lesser rate. So less steep, wider, and translated. This is plus 7 on the outside, so it's affecting just your output. It's not affecting your X value or the X amount horizontally. It's going to just change that Y direction. So less steep, wider, and translated up 7 units from our pre-image, our parent function. Okay, last one. Let's take a look. Oh, we got a lot of things going on here. A little triple threat. So let's start with the 4 on the outside. That's my A value, so it's affecting the steepness, and it didn't change the direction, so I don't have to say that it's the same. We're only talking about things that have changed. So steeper, narrower, translated. This is a plus 2 on the inside. Remember, that's affecting your X value, your X amount on the inside before you took the absolute value. Because it's a plus 2, we're going left. Because the value of X that would make this 0 is negative 2. So our vertex is going to be translated to the left 2 units, which everything else just follows from your vertex. That's why the vertex is like so powerful. Kind of like circles and vertexes, like math magic. Translated left 2 units. And this negative 9 on the outside, that's just your Y, your output. Y controls the vertical shifting or translating. Translated left 2 units and down 9 units. Cool. So now we're going to flip it. Before I gave you an equation and you told me the words, now I'm going to give you the words and you're going to give me the equation. Awesome. So let's take a look. Write an equation of the absolute value graph with a given description. The equation of a graph shifted left 5 units, 12 units down from this parent function. Make sure you realize what your parent function is because I'm going to try and trick you. Okay, shifted left 5 units. So from in here, shifting left means I need to add 5 on the inside. And sometimes I might think, oh, that's my H plus 5. And down, I think, oh, that's my K minus 12. I give myself little notes because I don't want to mess up. Minus 12, and we can call this Y equals. If you wanted to write it in function notation and put a little f of x action there, I mean, that's fun. So let's take a look at the next one. 17, 18, 19. Go ahead and work on those, and I will check in on you when you are done. Pause me. Okay, let's see how these panned out. The equation of the graph is shifted up 4 units. Remember, up, that's going to be a K value, and I'm adding 4. But notice I already have a minus 5 there, and minus 5 plus 4 is going to be negative 1. So our new equation is going to be Y equals the absolute value of X minus 1. Hope you didn't get tricked. I tried to warn you. Now, the equation of the graph shifted 2 units right. So that's an H value, and since it's right 2, I'm going to be subtracting 2. And then we need to also open down and be steeper. So this gives you a little bit of leeway. Because it needs to be steeper, your A value, the absolute value of A, has to be greater than 1, if you think about it. So there's a lot of possibilities here. You can say Y equals 2, and on the inside, the absolute value of X minus 2. So this value, it needs to open down, you guys. So it has to also be negative, opens down. So you can have Y equals negative 3, absolute value of X minus 2. Y equals negative 4, absolute value of X minus 2. You could have Y equals negative 5, absolute value of X minus 2. You could have, you knew it was coming, Y equals negative 22, absolute value of X minus 2. So thinking about that, just as long as the absolute value of your A is going to be greater than 1, or you can say just that A value is less than negative 1. Cool. Last one. Let's see how we did. The equation of the graph shifted left 6 units. Remember, that's an H value, horizontal on the inside, affecting that X direction. Left means adding 6. 8 units down, that's a K direction. Down means minus 8 from here. So on the inside, plus 6. On the outside, minus 8. We got this. Y equals the absolute value of X. 2 plus 6, 8. Down, 3 minus 8, negative 5. Left 6. Left 6 plus 6. Okay, perfect. Y equals absolute value of X plus 8, all minus 5. Ta-da! Congratulations. That is the last page and the end of 7.2a. Hopefully I didn't make too many mistakes for you. Have a fabulous rest of the day. Enjoy, stay hydrated. It's going to keep getting warmer. And be kind. Be kind to yourselves, be kind to others. Thanks, you guys. Video bar out.